Given the name of an ionic compound, these are the steps to take to write the formula. So we're given the name lithium oxide. Notice that it's the metal first and then the nonmetal. And then also notice that the ending is IDE, just like we saw with our covalent molecules. So step by step, this is what you do. Step 1, you write the symbols, including the charge, for both the cation and the anion. So for lithium, I know that the symbol is Li, so capital L, lowercase I, and I want to include the charge, so that's +1. The anion is oxide, which is oxygen, and the charge for oxygen is -2, 2 minus. So that's your first step. Now, determine how many of each cation and anion you need in order for the overall charge to be 0. So I take my cation and I'm going to put it on the left side, and I take my anion and I put it on the right side. I'm going to keep the cations together and the anions together. Now remember that the end goal is to get the total charges to equal 0. So in this case we have +1, here we have -2. I'm going to need another lithium so that my total charge is +2, and that matches with my -2. +2 minus 2 is equal to 0. Well, how many of each did I need? I needed 2 lithiums and I needed 1 oxygen. So those will be our subscripts when we write the formula. So step 3, we write the formula. Remember that the cation is first and that the anion is second, or in other words, the metal is first and the nonmetal is second. So I write Li, and how many Li's did I need? I needed 2. And then I write O. How many O's did I need? I needed 1. And again, I don't write that 1 here because when I write the letter, it's assumed that I already have 1 oxygen. So our second example is strontium sulfide. Step 1, we begin by writing the symbols with the charge for the cation and the anion. Strontium is Sr, capital S, lowercase r. Strontium has a charge of +2. Sulfide is sulfur, and that has a charge of -2. So step 2, how many of each do I need to equal 0? So I'm going to write the cation and anion here. Well, these charges match up, right? So it's +2 minus 2 is equal to 0. I don't need any more of each ion, so I'm going to write SRS. I don't need a subscript because 1 of each. I only needed 1 of each, and so I don't need to represent that by using the 1 subscript. Let's take a look at example number 3, aluminum oxide. So again, as you can tell, the steps are exactly the same. The symbol is Al +3. Oxide is oxygen -2. How many of each do I need? So let's start by writing the cation and the anion. Well, how can I get these numbers to match up, the 3 and the 2? What is a common multiple between 3 and 2? It's 6, right? So how do I get this to 6, the aluminum? I need another aluminum to get to +6. And for oxygen, I need 2 more, 2, 4, 6, and that makes it -6. +6 minus 6 is equal to 0. So how many aluminums did I need? I needed 2, and oxygen, I needed 3. So we have the formula Al2O3. So for these practice problems, again, you're going to follow the same steps. So step 1, write the symbol and charge for the cation and the anion. Step 2, how many of each do you need to equal 0? And then step 3, write the formula. Again, you don't have to write the 1 subscript because when you write the letter, it's already assumed that there is 1 atom of that particular element. Now, as you get comfortable, just like we did with covalent molecules, you can skip steps 1 and 2 and can go from the name straight to the formula. So go ahead and pause the video here and take the time to go through these 5 practice problems. Now let's talk about the metals where we did not assign oxidation numbers. These metals were not assigned an oxidation number because these metals have multiple oxidation numbers. They can lose different amounts of electrons depending on what it is bonding with. Now these metals are known as MOMs, to help you remember. Multiple oxidation metal, MOM. So for example, manganese, which is atomic number 25, actually has 4 oxidation numbers, +2, +3, +6, and +7. The other ones where we actually highlighted and wrote the oxidation number, those are set. For example, potassium, atomic number 19, it will always have an oxidation number of +1. Oxygen will always have an oxidation number of -2. It doesn't have any other oxidation numbers. But again, these MOMs have multiple oxidation numbers. So for example, take a look at the top right corner of the screen. I give you 4 different formulas and 4 different chemical names. However, what do you notice about the elements that make up the formula or name? What do you notice about the elements that make up the compound? That they have the same elements, right? It's manganese and bromine for each of those compounds. But all of the 4 compounds have different formulas, and technically it's different names because manganese has 4 oxidation numbers. So let's highlight same elements and different formulas. And again, it's because manganese is a MOM. It has multiple oxidation numbers. And in the name, you'll notice a Roman numeral here. The Roman numeral actually tells you the oxidation number of the metal. So you don't need to look at the periodic table to figure out where the element is located. If you see a Roman numeral, the Roman numeral tells you the oxidation number. So let's take a look at some examples. Here we have the name iron 3 oxide. You'll see that the steps are exactly the same as what we did previously. We're going to first write the cation and the anion and include the charge. So remember that the Roman numeral tells you the charge, the oxidation number of the metal. So all I have to do is look at the periodic table to find the symbol iron, which is Fe. The Roman numeral tells me the oxidation number, so I'm going to write 3+. And the anion part, that's always the nonmetal, so I'm going to know the oxidation number. This one is oxygen -2 or O2-. Now, if you don't know your Roman numerals, please get familiar with them. I did put a picture right here, numbers 1 through 10. Step 2, determine how many of each you need in order for the overall charge to be 0. So again, I'll write the cation, I'm going to write the anion. What's the common multiple between 3 and 2? It is 6. So I need another iron +3 to get to +6. And I need 2 more oxygens to get to a total of -6. +6 -6 is equal to 0. So then I write the formula Fe2O3. Here's the second example, iron 2 oxide. So you notice that it's similar to our first problem, iron 3 oxide. However, what's the difference here? Is that the charge is different. So instead of the +3, it's now +2. Again, I know that because of that Roman numeral. The anion is the same, O2-. So here, how many of each do I need to equal 0? I really only need 1 of each, right? Because it's +2 -2. So I write the formula as Fe O. So again, because the oxidation number is different, the formula is different, even though it's the same element from the first problem to this problem, but because of the oxidation number, the formula is. So again, go ahead and pause the video here to work on these practice problems. And again, you can skip steps 1 and 2 if you are comfortable and don't need to go through the steps to get to the final formula. Now, given the formula of the ionic compound, let's learn how to write the name. So again, 3 steps. We are given the formula MgO. And notice again that this is Mg is a metal, O is a nonmetal. That's what makes it an ionic compound. So step 1, let's write the names of the cation and the anion. So here the cation is magnesium and the anion is oxide. Remember, we have to change the ending. Step 2, is the cation a mom? Remember what mom stands for. Is it a multiple oxidation metal? We'll find magnesium on the periodic table. Magnesium is number 12. Does it have multiple oxidation numbers? No, you know that magnesium is +2. It will always be +2. So no, it's not a mom. So we skip this here. And step 3, we're going to write the name by putting it together, magnesium oxide. Second example, ALP. Step 1, write the names of the cation and anion. Al is aluminum. P, with the ending changed, is phosphide. Is aluminum a mom? Nope. We know that aluminum is +3. It will always be +3. So step 3, let's write the name, aluminum phosphide. So let's take a look at this example, HgBr2. What is the cation? Mercury. What is the anion? Bromide. Now, is mercury a mom? Does it have multiple oxidation numbers? Do you know the oxidation number of mercury? You don't know the number, right? So it is a mom. Mercury is a mom. So now we need to calculate the oxidation number. And in order to do that, we're actually going to look back at the formula to look at how many atoms of each we have in the formula, or according to this formula. So according to the formula, we have 1 mercury and we have 2 bromines. Now, I don't know mercury's oxidation number, so I'm going to write a question mark there. However, I do know bromine's oxidation number, and that's -1. So I'm going to write 1 minus for each of these. So what's the total charge on the anion side? -2. That means on the cation side, it needs to also be +2, because remember, +2 minus 2 has to equal 0. The overall charge of the compound is 0. So if the total charge of the cations has to be +2, and there's only 1 mercury, what must the charge on the mercury be? Well, it's got to be +2. So how do I put that in the name? Remember, for moms, we have a Roman numeral to indicate the oxidation number. So to write the name, rewrite mercury, Roman numeral 2, in parentheses, and then bromide. Mercury 2, bromide. Let's take a look at one more example together. Cu3n. The name of the cation is copper, and the name of the anion is nitride. Is copper a mom? Yes, it is. So let's calculate the oxidation number. So again, we need to look at the actual formula, and we're going to list those atoms in our table. So there's 3 coppers and 1 nitrogen. Do we know the oxidation number of the copper? No, we don't. So we're going to write question marks here. But we do know nitrogen's oxidation number, and that's 3 minus, or minus 3. So the total charge of the anions is minus 3. That means the total charge of the cations has to be plus 3. So if there are 3 coppers and it has to equal a total of plus 3, what is the oxidation number for each of the copper atoms? Plus 1. 1 plus 1 plus 1 is equal to plus 3. So how do we write the name? We write the name as copper, Roman numeral 1, because it's plus 1 as the oxidation number for each copper, nitride. So our final answer is copper 1 nitride. So pause the video here and complete these practice problems. Given the formula of the ionic compound, write the name for these ionic compounds.